So today we're going to talk about our Pitot Static system. We have our pitot tube and we have a static port. The pitot tube references ram air pressure and the static port references static air or static air. So speaking of that, the pitot tube connects to the airspeed indicator. That is the only thing it connects to, and that will tell us our airspeed by measuring the ram air pressure coming inside the pitot tube. Secondly, we have the static port. The static port connects to the airspeed indicator, the altimeter, and the VSI. And as we said earlier in the plane, it connects to the airspeed indicator to reference the outside pressure, because as we go up in altitude, air density decreases. It connects to our altimeter, based on the change in pressure, and will let us know how high we are. And our vertical speed indicator is trend information, so it will show us a constant climb or a constant descent. Now, while flying in IFR conditions, what happens a lot is we can get some icing. And if we had icing on our pitot tube, we have a nice little switch inside our airplane, and we can turn on the pitot heat, and it will heat up the whole tube, and it will melt the ice. If, for some reason, it did get blocked and our pitot tube did not work, our airspeed indicator would not read. Now, if for some reason our static port got blocked or maybe it iced over, it would block that static air inside the system. So our altimeter would be stuck at whatever previous altitude we were at where it got blocked. Our VSI would read 0. And our airspeed indicator would work, however, it would be inaccurate. If that did happen, we would pull the alternate static source inside of our airplane, and we would get our altimeter and our VSI. So we're here sitting in our Skyhawk, and we're going to talk about our 6-pack. Here we have our airspeed indicator, we have our attitude indicator, we have our altimeter, we have our vertical speed indicator, we have our heading indicator, also known as the directional gyro, and we have our turn coordinator. Today we're going to be talking about some systems. So first we're going to talk about the airspeed indicator. The airspeed indicator is analog. It works off of ram air from the pitot tube, and it references the static port to find out the pressure actually coming in. Speaking of the Pitot Static system, we also have the altimeter, which works just off the static port. And this will tell us our altitude based on the difference of pressure from what we set on the ground. And thirdly, we have the vertical speed indicator. And the vertical speed indicator works based on the rate of change of the static port. So it will show a climb or a descent. What's important to note about the vertical speed indicator is it's good for trend over time, not quick changes. Another system we have gyroscopic instruments. We have our attitude indicator, and we also have our heading indicator. They are both powered by vacuum, and our attitude indicator will show us what the horizon is, very important in IFR conditions, and our heading indicator will give us a good sense of direction, which we match to our magnetic compass. Thirdly, we have the turn coordinator, which is also gyroscopic. Commonly, these used to be vacuum powered, but now, as you can see right on our instrument, it is powered by electric, direct current, and that will tell us our rate of turn. We also have our coordinator, which will tell us if our plane is coordinated during